So I want to make sure first, before we get started, that you guys have just a fundamental understanding of how roots work. So let's talk about that. What's today? 27th. Yep. Sounds like we've got chaos across the way. Is that coming from Spanish? You probably know I'm going to say this, but here it goes. Would one of you pull our door shut? We've got absolute bedlam over there. That Spanish there, Jesse? Is that Spanish? Little turkeys. I hope I don't overwhelm you today. I gave you that resource, that piece of paper, so that you wouldn't feel like it's something you have to conjure up on your own. It's just a resource now. Please don't lose it. Like I said, take care of it, put your name on it, and feel free to add some things. There's not a lot of room, quite frankly, but you could make your own. If there are little things you find yourself having to do that aren't on the sheet, then you're like, I'll just make my own and add on. That would be just fine. So I'm assuming you guys know some basic stuff, but I would be remiss if I didn't ask. So here we go. You guys all know what this symbol is? It's called a radical, you're right. And in this particular case, it has a very specific name. This type of radical is called a square root. I think you guys have probably seen those before, but if not, let's talk basics here. What is the square root of 25? It is. So remember, the definition of a square root is what number would you have to multiply by itself to make the number on the inside of the radical. That symbol itself is called a radical. All right. So like the square root of 25 is 5. That's one you guys all probably already knew. We can change the radical, however, to a different flavor. If I put a number up here on the radical, it's still called a radical, but now it's called something else. Do you guys know what that particular one is called? It's called a cube root, C-U-B-E, with no D at the end, just a cube root. And the cube root is by definition, so if I gave you like the cube root of 64, you have to be careful, because if I said the square root of 64, you'd say 8, because you probably just know that, but it's not that. So the question now becomes, what number do you have to multiply by itself this many times to make 64? 4, right. And again, you can find that right on your resource, but I want you to have a little understanding kind of behind the scenes of why that works. So a cube root is asking you what number cubed times itself 3 times makes the number on the inside. And that's why that one equals 4. Okay. And of course, we're going to extend this now. We could do anything we want, by the way, but in this class, we're going to go only probably to 5th. So this is called, there's no fancy name for this. There's square root, cube roots, and then this one we just call 4th root. So like the 4th root of 81. Your sheet will tell you, but you probably could do this one without the sheet, right? Because you could think, okay, what number would I have to multiply by itself 1, 2, 3, 4 times to get 81? And the answer is 3, because 3 times 3 is 9. 3 times 3 is 9, and 9 times 9 is 81. So we come to understand that the 4th root of 81 simply equals 3. And then we can finally extend it to the last level, and that is to say a 5th root. And again, this can go as far as it wants. You can take the 182nd root of something. At that point, you obviously want to use your calculator. But the 5th root is, again, by definition, what number times itself 5 times makes what's inside. So if I put like, let's see, what's the 1024, I think. And that's probably on your sheet. But what number would you have to multiply by itself 1, 2, 3, 4, 5 times to equal that answer? And the answer is 4. So that's why we say that the 5th root of 1024 equals 4. So I want you to understand that roots are not division. Okay, if I wanted you to divide by 5, I'd ask you to divide by 5. I'm asking you to come up with what number, when raised to that power on the outside of the radical, makes the number on the inside. And the last little thing, and I won't really call you on this too much, but just occasionally, this number right here and here and here, And you might think I'm crazy because that first white arrow isn't pointing at anything, is it? But if there had to be a number there, what would it be? It's not a 1, it's a 2. Remember, these are second roots. So we assume by default that the number that would be there is a 2. This is a weird time in math. I know we're used to 1s being invisible, but on a root that's not otherwise stated, we assume it's a second root called a square root. So that number would be a 2. Anyways, I want you to know the name of that number out there. That number is called the index. I sometimes jokingly call it the flavor because it's like, what flavor of root are we working with? But really, it's called the index. And so when you draw a radical sign, the number that you put to determine the flavor of the root, that number is called the index of the root. So far, so good? Okay. Now, the next thing we have to talk about is this. I want to have you put that statement down, and then I want to give it a second. I'll sip on some coffee here while we let that simmer and see if you can crack my code. Because I've never asked you to do an exponent that is a fraction before, but now today that's all we're going to do. Can anyone think of like the logic or the rationale as to where do I get away with saying that the 64 to the power of 1/2 equals 8? What does that mean, Gage? Don't divide it. We're going to not use the word divide today at all. Nope. Starts with an R. And it's something that trees grow down into the earth that makes them stronger. Right. So what that 2 is the index of a root. I don't know if you cracked that code or not, but maybe as you start to practice more, you start to see a relationship between 64 and 8. And you go, I know that 8 is the square root of 64. This number that I'm circling in green is the index of a root. So I make a second root of 64. And that's why the answer was 8. Got that? That's one of those things on YTOP that if you don't know it, it's like a foreign language. But once you know it, then you go, oh, I can handle this. Like, I'm not scared anymore. I understand. And we're going to leave the top number out for just a couple more examples. I'm going to give you a couple more practice, guys, and let's see if you've cracked the code well enough that you can figure out what in the world I'm talking about. Let's do 27 to the power of 1/3. I'm going to ask you again, what is the 3? It's the index. Thanks. Just start using that word and you'll get used to it. It's the index. I don't care if you say the flavor. It's the flavor of the root. And so someone's telling me that I need to do a third root or a cube root of 27. And then I look at my resource page and what is the cube root of 27? So the answer to 27 to the power of 1/3 is 3. Let's go again. How about 32 to the 1/5? What is the 5? It's the index. So someone's telling me to build a root with an index of 5. In other words, a 5th root, and I'm going to stick the 32 inside. And what is the 5th root of 32? It is 2. And again, you'll use the resource a lot, like almost every problem today. I get that. Full respect for that. I understand. But eventually you'll get annoyed with having to keep looking and your brain you'll just start to know things that you kind of didn't think maybe you would ever take the time to know. When suddenly you know the cube root of 343 is 7, you're just like, oh, did I just do that? And it's like, it just happens, whether you wanted to or not. So are we all in okay? It would be a good time to ask if you're not sure what's going on. The bottom number when you have a fractional exponent is the index of a root that you will build. Now I'm going to put another math problem up here and I'm going to see if you can crack my code. Are you ready? All right. 64 to the 3/2 equals 512. This is the target objective. We have reached the top of the lecture, the lecture mountain for the day, and this is what I wanted to get us to. So let's knock out 6, 7 of these practice, and then I'll let you start doing your homework. And right now, that looks like, you seriously, can you do that without a calculator? You can. So let's talk about who's who. We talked about this just now. What is the role of this 2? What's his job? He's the index. He's like, I'm your root guy. So he says, make a root with an index of 2. And what do we do with the number 64? We put it inside, which begs the question, like, you know that the square root of 64 isn't 512. It's 8. So then you go, wow, how'd you get 512? Well, there's a new number in play here. What is his job? He's not a multiplier. He's an exponent. So what we learn is that each member of the fraction has a job. Each one is very trained in their job. The bottom one says, I know right where to go, sir, yes, sir. I will make a radical for you, a root. And then the top number says, all right, you go do that. And then I'm going to apply myself. Wait for it. You ready? Right up here. And that's what each member of the fractional exponent does. The bottom says, make a root like me. The top says, go ahead and do your thing. When you're done jerking around over there, then let me know. And raise to me, to my power, to me. And what is 8 to the third? There it is. So that is how you attack fractional exponents, is you take the bottom one first and make an index or a root. And then the top one comes in last. And for the record, in case anyone, like, let's say there was a mom or dad or an older brother watching this video at home, they would tell you that I'm keeping a little information from you, and it is this. This 3 can also go inside. Why is that a bad strategy? Because then you got to do 64 to the third. The heck is 64 to the third? So really the goal is, when we do this process, we're trying to find a workaround to make ourselves quick and fluent. And the moment I got to stop and type 64 to the third in my calculator, I've really kind of defeated the whole purpose. So FYI, the power thing, that's the top number, he can go inside, but it's never a good idea. You want to leave him as the afterthought so that we can keep doing it just with our brains, our cranial supercomputers up here. Ready for another one? 4 to the 5 halves equals what? Each number has a job, right? That's the hardest part of today, is to get you to make sure that this isn't a coin toss. I was close. You got to know tight. Who's the 2? What's his job? He's root guy, right? He says, make a root like me, make a 2th root, a 2nd root, a square root. So I go, okay, I can do that. I'm going to make a square root. What number am I going to put inside? The 4. And then there's going to be an exponent sitting right up here. What's it going to be? The order of operations, the order in which we do things, is critical. What is base simple math? What is the square root of 4? Square root of 4 is 2. And what is 2 to the 5th power? Jackpot. So just like that, you can do 4 to the power of 5 halves by just square rooting and then raising to the 5th. Let's go again. Got it? Let's do 729 to the 2/3. Use your resources now. They're going to start getting a little bit harder, okay? This looks unmanageably impossible, but not with our resources that we have. I'm going to give you guys a moment and see who can crack it first. No calculators allowed. Everything you need is on that 2-sided thing I gave you. Use one side for your roots and then flip it over and use the other side for your... I tried to get it all on one side when I was cutting and pasting, and I was like, yeah, no. Say again? Good job. We have one winner up here. Others of you might have had it, but I heard it right here first. The answer is 81. Let's talk about why that is. What did this 3 do? He's your index. He said, make a root with me. So I go, okay, I'm in the cube root zone now. And what number do I put inside? 729. And then what does this 2 do? He says, apply me when you're done screwing around with your little dumb radical thing. So use your paper, look at the roots page, and find me the cube root of 729. What is it? It is all day long. It's going to be 9. And what is 9 squared? Well played. It's not as hard as it looks. Let's go again. Let's do 1. Say again. Uh-huh. It does, right. What you'll find in mathematics as we go is that there are other ways, like you'll notice that 3 to the 4th is 81, but you'll also notice that 9 to the 2nd is 81, right? There are tons of examples like this in math. We want to pick the one that is the most compact, so we're always going to pick the one that involves the least exponentiation. Okay, and if you do see that, if you see that there are multiple ways to make a number, stay focused on what we're doing here. You need to focus only on the cube roots, look just there, tunnel vision, and then square that answer. It's not a bad question. I get where you're coming from, but you'll see that a lot. Because if you think about it, nines and threes, it takes a couple threes to make a nine. So it takes less nines to make 81 than it does to take three or threes, right? And that happens all the time. Like 4 squared. What's 4 squared? 16. What's 2 to the 4th? 16. So yeah, very valid concern. Let's do 125 to the 4/3. Good job, you guys. And that took a nice amount of time. Took about 30 seconds, 20 seconds, exactly what I would expect. And I saw you guys doing exactly what you should do. Saw people's fingers moving, getting a number, writing it down, and then flipping that page over. That's how this works. So we started by taking the cube root of 125. We went and found that on our sheet and said, oh, that equals 5. Nice. And then we took this 4 and said, you're my exponent, dude. Come on down here. And then we flipped the page over and knew that 5 to the 4th was excellent work, everybody. Everything you need on today's practice assignment is on those pages. Do you feel like you need more practice, or are we good to green light this and give it a shot? We're good? You're doing something right now. Like imagine if you'd walked in the room today and I said, by the time you walk out of here today, you're going to know how to do problems like this in your head. You would have probably thought I was loco, right? So it's pretty cool stuff. And we'll use this a lot also in Algebra 2. If you take that class, just FYI. So we want to get you good at it, obviously for Y-top, but we want you to be good at it anyway so we can not dork around with it when we need to. Good? You good? Good? All right, cool. I'll probably keep the recording paused, and then if you guys have questions, because usually that's how it goes, then I'll throw them back in. So